Let's solve for the equations of the tangent and normal lines to the hyperbola x squared minus y squared equals 7 at the point -4, 3. Let's start by finding the derivative dy dx using implicit differentiation. Taking the derivative of both sides with respect to x, we get 2x minus 2, y times dy dx equals 0. Solving for dy dx, we get dy dx equals x over y. This will give us the slope of our tangent line at any point on the hyperbola. Now let's find the slope at our specific point. Plugging in x equals -4 and y equals 3, we get that the slope equals -4/3. Let's graph our hyperbola and point to visualize this. Here's our coordinate system. And here's our hyperbola x squared minus y squared equals 7. Our point -4, 3 is here. Now, let's find the equation of the tangent line. Using point-slope form with our slope of -4/3 and point -4, 3, we get y minus 3 equals -4/3 times x plus 4. Simplifying to slope-intercept form, we get y equals -4/3 x minus 2/3. For the normal line, remember that it's perpendicular to the tangent line. Therefore, its slope will be the negative reciprocal of the tangent line's slope. The slope of our normal line is 3/4. Using point-slope form again with slope 3/4 and our point -4, 3, we get y minus 3 equals 3/4 times x plus 4. Simplifying to slope-intercept form, we get y equals 3/4 x plus 6. Let's verify our work. First, we can check that our point lies on both lines. Second, we can confirm that the lines are perpendicular by multiplying their slopes. -4/3 times 3/4 equals -1, confirming they're perpendicular. In conclusion, we've found that the tangent line is y equals -4/3 x minus 2/3, and the normal line is y equals 3/4 x plus 6. Our graph shows these lines intersecting at our point -4, 3, with the tangent line being parallel to the hyperbola at that point, and the normal line being perpendicular to it.